Okay, welcome to genetics. So this is Genetics in the Name of Love. I love this lab. It's it has a great engagement activity to get students really interested in the genetics. So if you have, normally what I do is I just start the students off. I let students each read a paragraph of the beginning introduction, and I set up the scenario. I usually draw it on the board. But what the scenario is that we have Jack and Jill. So this is Jack, and we have Jill, who's got curly hair, and they want to get married, okay? And Jack is concerned because Jack has a mom. This is Jack's mom and a dad. And dad is Donald. And then Jill only has a mom. I'm such a good artist. Okay, so Jill only has a mom because she is the product of an anonymous sperm donation, and Donald was a sperm donor in his college years. And so obviously we have a big dilemma, right? And Jack's embarrassed and he doesn't want to ask Jill for a blood sample because how mortifying is it to admit that your dad was a sperm donor. And so he's trying to figure it out using genetics if it's even possible that Donald could be his fiance's father. All right, so they're in love and they want to be married. Okay, so that's the scenario, and so it's really funny and the students get a kick out of it, and we're going to try to solve this. So the very first thing I do is I have them do question number 1. So just talk with your group about question number 1. And if they want to use their whiteboards and write some ideas down, that would be awesome, and they can display their ideas. And so it asks them what kind of genetic information you could gather that might give you an idea, and from whom would you gather this information. So I'll walk around to the groups, let them answer these questions, and then bring them back together for a class discussion. And things they might list, and they're listed in your instructor guide, but things they might list, any of the Mendelian traits. So the hitchhiker's thumb, the widow's peak, well, we do freckles in here, which is not exactly as clear. And some people might mention eye color, or hair color, or skin color, and go ahead and write everything down that people mention. And then you're going to sort of explain to them that some of these things are going to be easier than others, because some of these things, like eye color and hair color, they're controlled by multiple traits, and so it's really hard to track those. But then you've got other traits like widow's peak or hitchhiker's thumb that are, or earlobe attached or unattached, that are controlled by one gene, and so they're a lot easier to trace. And blood type's a great one because we know exactly how that one is genetically modified, and so we can trace that one. So your point that you're going to try to make with students is that we want to pick things that are genetic, right, and things that are easy to trace. And so that's what you're going to get listed up on the board. Once you do that, then you're going to have them investigate. Now, I prefer if they use the laminated chromosomes just so they get something tangible in their minds of what would be inside of the nucleus of a cell. But if you use the laminated chromosomes, okay? So they're going to get out the laminated chromosomes, and at each table, two of them are going to be Donald, and 2 of them are going to be Daisy. So this is Daisy. Okay, so 2 of them are going to be Donald and 2 of them are going to be Daisy, so that they can see how things would come together. Now, some of the things to keep in mind when they're setting up their chromosomes, they might be asking, what in the world, why are some pink, some are blue, the ones in the bag are pink and blue. And you want to tell them that the way that I describe DNA is that DNA is like a recipe book. Okay, so everybody has the full, complete recipe book with the recipes for everything you could possibly have. But everybody actually has a redundant copy of the recipe book. So for chapter 1 that might be on cookies, I have a chapter 1 that my dad gave me, and I have a chapter 1 that my mom gave me, and that's represented. If I were Daisy, then my chapter 1 from my dad would be the blue chapter 1, and my chapter 1 from my mom would be the pink chapter 1. And these chapters are identical. They have the same recipes, except if you look up the chocolate chip recipe, for instance, in my pink recipe book, it might call for raisins. And if you look up the chocolate chip cookie recipe in my blue recipe book, it might have oatmeal added. Okay, and so there are slight differences in the recipes, but they're still the same recipe. I only need to know how to make chocolate chip cookies, but depending on which recipe I read, or if I decide to read them both, then my cookies that I make are going to have raisins and oatmeal in them. All right, so everybody has a redundant copy, and so that's why we say we have 46 chromosomes, but really it's 23 pairs, because we only have 23 chapters of our recipe book, and we get one chapter from each parent, a duplicate copy of the chapter from each parent. Now in our activity, we're only going to look at 4 of the chromosomes. I've got them listed there: chromosome 1, chromosome 9, chromosome 16, and the sex chromosome pair. Okay, so they're going to get those out and put them on the table, and then we have a wet erase marker, so lab tech makes sure that there are 8 bags of chromosomes and 8 wet erase markers in case they want to mark something on them. They can do all of the marking actually on their student guide, so it's really not necessary to have the chromosomes, but like I said, I think it's really useful for them to practice laying them out, at least at the beginning. As they start working on the activity, you'll probably see that they're like, we don't really need the chromosomes, but having them lay them out at the beginning and get a feel for what's going on is actually really helpful. Okay, so once they've got their chromosomes out, and I would tell them to read that paragraph on how to set up the chromosomes, walk around each table and make sure that they've got them set up correctly. And if they're a boy, here's one of the other common mistakes that people make, is if they're a boy, they will have the pink X and the blue Y, which is right. But if they're a girl, a lot of them will set up for Daisy 2 pink X's, because they think, well, this is an X, so it has to be pink. And you need to remind them that boys have an X and a Y, and when they donate that X to their daughter, it's a blue X. So Daisy should have a blue X and a pink X. Okay, and that's something you can make the point of at each of the tables. It's a really good thing to talk about. All right, so once they've got it set up, go ahead and just say, all right, go ahead and do questions 2 through 6. And you're going to be walking around circulating as they do questions 2 through 6. Okay? And so let me go through those so you know the answers to those. All right, so they're looking at a human karyotype, which karyo means nucleus, type means photograph or picture. So it's a picture of the nucleus, and inside the nucleus we have all the chromosomes. And so number 2 asks, what do you notice about the pairs? Well, the things they should notice is that they're of equal length, that they look very identical in their banding patterns. And the banding patterns have to do with the stain that we use and how compacted the DNA is or how many GCs there are. You don't need to go into detail about it, but just tell them that the banding pattern is sort of representative of what recipes might be on there. And so if they have similar banding patterns, they probably have similar recipes. Number 3 asks them, what do you suppose that means? That's what it means, that they're similar recipes. Number 4 says we call these pairs homologous. Notice it's not identical, it's homologous. So ask the students what that means. What do you think it means to be homologous? And going back to my analogy of the recipe book, they carry the same genes in the same order, but not necessarily the same recipes, or what we call alleles. And I think actually this is where you can introduce, it's introduced in number 6, but feel free to introduce it. When you get back together as a group, you're going to define homologous. So homologous means same genes in the same order, but not necessarily the same alleles. Now again, just to re-emphasize some of your teaching techniques, you want to make sure you're always putting terms on the board that they need to know with the definitions, and you go ahead and write them out. And again, you're going to ask the students to help you define it. So you're not just saying, hey, by the way, this is what this means. You're going around and talking to each table, and they're coming up with the definition, and then you're synthesizing it together and putting a definition on the board. So it does not have to be word for word my definition, as long as it conveys the same principle. Let the students help define the word. So that's homologous. So then number 5 says, let's pretend this cell came from the testes of a male, i.e. Donald, okay, and he's going to make sperm. How many total chromosomes does this original sperm-making cell have? So remind them, this is not the sperm, this is the cell that's going to make sperm. And this cell has to make sperm over and over and over again. We have to keep having the same cells in there to make sperm. And so the original cell has all 46 chromosomes. In B, it says the term for the number of chromosomes in the original cell is diploid. So you're going to put diploid on the board. And I like to point out that ploid means number, di means 2, so it's 2 numbers. So ploid is really how many chromosomes a parent donates. Oh, how many? How many chromosomes a parent donates. Now I'm sure there's a better, more official definition, but that's the idea. So for our ploidy number is 23. So if we are diploid, we have 2 times that. We have 46. Whereas haploid, which actually means half the number, we end up with the 23 chromosomes. Excuse me. So how many chromosomes does the original sperm cell have? It has 46. C asks them how many chromosomes would you want in a sperm or an egg cell. They should be able to just intuitively decide that there should be half the number of chromosomes, or just ploid. I don't know if I should call it just ploid, but anyway. So haploid is how many chromosomes are in an egg or sperm cell, and so that should be 23. And when it asks them why, they should be able to come up with the obvious reason that if you gave all 46 and the other parent gave all 46, then with every generation, our genome is going to double. Right? And you don't want that to happen. You want to end up the same as your parent. And so the parent gives, one parent gives half, the other parent gives half to get a whole. Okay? What was I going to say about that? Oh, you might consider introducing the term gamete. Gamete is just the generic term for egg or sperm. I think it's used in here, and I use it a lot, so gamete, egg, and sperm. Okay? Then number 6 says, remember that homologous chromosomes have identical genes on them. This is where alleles is introduced. So you want to make sure that you write down alleles and get a definition, which is just alternating versions of the same recipe. Okay, just different versions of the same recipe. So number 6 is tricky, and students struggle with this. And if they're struggling with this, the coolest, best way to resolve this for them, and I think it's in your instructor guide, is have them lay out their chromosomes. So Donald and Daisy's chromosomes are laying on the table, and they've got all the 4 pairs. They have 8 chromosomes sitting there, and you say, okay, so this is Donald, and he's going to make sperm. How many of these 8 chromosomes is he going to give to the sperm cell? And the students will say 4. So I'm going to illustrate this here. So Donald's got his 1, 9, I think it's 16. And the little y, 1, 9, 16, and the x. So that's what Donald looks like. And so you have those laying on the counter, and I'll say, all right, so how many of those 8 do you want to give to a sperm? And they say 4. And I say, all right, no problem. I'll take these 4. And just say that and wait. And whatever group you're sitting at, the students will go, wait, no, you can't do that. Well, why not? Why can't I take those 4? I just need half the number, so does it matter which 4 I take? And it will become very obvious to them, well, yeah, you have to give 1 of each of the pairs. Okay, so if we're looking at those answer choices, A through G, which ones of those, and when it's saying dad and mom, it's talking about Donald's dad and mom, the pink and the blue. So the blue number 1, blue number 9, blue 16, blue Y. That's answer choice A. All right? And if that's the case, as long as you have a 1, a 9, a 16, and a sex chromosome, it's going to work. Now they might say for A, yeah, but it all is the blue ones. Does it matter if I choose all blue ones? If I chose this one, this one, this one, and this one, does that matter? And the answer is no, it doesn't matter. It just means that that particular offspring is going to look a lot like grandpa, because he got all of grandpa's genes, okay? Or if you pick all pink ones, it's going to look a lot like grandma. Now, obviously, you're getting input from the other parents, so it's not going to be identical to grandma or grandpa, plus crossing over and all that other stuff. But there are 4 answer choices that are correct there. Your instructor guide talks about it. As long as it has a 1, a 9, a 16, and a sex chromosome, it will work. Okay, so once they get through that, then you're going to start going through the genes. And the key with these, your instructor guide describes, the inheritance pattern of these genes and how they're caused and all of that. Don't tell the students that until after they struggle with it, okay? So don't get up here and lecture to them about how freckles are determined with the MC1R gene and all that, and then ask them to figure it out, because you just told them. So we're going to start out with, okay, so you're going to tell them, we're going to look at 5 different traits. We're going to look at freckles, we're going to look at the blood antigens A, B, and O, we're going to look at the blood antigen Rh factors, we're going to look at color vision, and we're going to look at nail patella disorder, okay? And they're going to learn more about these, but what we're going to do is we're going to look at the person's appearance, and we're going to try to figure out what underlying recipes they have. And there are words, there are terms for the appearance and for the recipes. Does anybody know what that is? This is what I would ask students. And obviously the answer is that phenotype is appearance, and genotype is their recipes or their alleles. Okay? So you want to introduce those terms. You'll notice that this particular lab is packed full of terms. And the terms are all in the instructor guide and in the student guide, and they're bolded and they're really emphasized. So just make sure that they get those. Okay? All right, so they're given a chart in their student guide that has each of the things we're going to look at, the 5 different genes. 1, 2, 3, 4, yeah, 5 different genes. And then the phenotype, genotypes of Jack, Jack's mom, Jack's dad, Donald, Jill, and Jill's mom, Daisy. And that's what we're trying to figure out, okay? So they should have that out on their table the whole time. And so the very first one, you're gonna say, all right, go ahead and do number 7. Okay? So have them do number 7 and pause. Walk around. And number 7 just says they're starting with the freckles gene. It's carried on chromosome 16. And looking at the parents, so you go back up to the chart and you can see that for freckles, and we'll write it up on here. So for freckles, if we were doing freckles, Jack, let's see, pause for a second.